All right, here we go. Test review. Okay, so first thing we want to do is we want to go ahead and we want to write our components for all of these vectors. So it looks like I'm going left 1, 2, 3, up 4, 5. Okay, so A is negative 3, 5. Again, guys, remember you go from the initial to the terminal. Okay. For B, it looks like you're going over 1, up 1, 2. So 1, 2, and then C is actually really easy because all you're doing is going down 2 and not left to right, so just be 0, negative 2. Okay, and so it wants me to do A minus 2B. Okay, so A is going northwest, and then 2B, normally we go northeast, but since it's got a minus sign, we're going to do opposite. So I'm going to start, I'll just start down here for my initial, and then I'm going left. 1, 2, 3, up, 1, 2, 3, 4, 5. There you go. Put a point there. Draw a line. And there we go. So then we'll label that there. Now I want you to label this, okay? So you're going to label this vector A like that, okay? Then we're doing opposite to B. So I need to do, so instead of going right 1, up 2, I'm going to go left 1, down 2. Draw a vector there, label that B. And then same thing, left 1, down 2, 1, 2. Point, draw another vector, and there you go, there's another B. Well, we need to put negative signs in front of them, right, because it's negative 2B. Now, this is my terminal point. My initial started from when I drafted A, and so we're going to go ahead now and connect. And so here we go, there's my resultant, and I'll shade it in a little bit darker for you so you guys can tell. Okay, it's real heavy there, that heavy line, that's your resultant. So let's go ahead from that initial to that terminal, see what we get here for our components. So over, looks like 1, 2, 3, 4, 5, up 1. So the component form of U is going to be over 1, 2, 3, 4, 5, so negative 5, up 1. Okay? And so now when we see this right here, this means it just wants us to find the magnitude. So we're going to, this is going to be, we're going to take negative 5, square it, plus 1 squared, and we're going to find out that we get the square root of 26. Our magnitude is square root of 26. Okay? All right, number two here, we're going to go ahead, we need to graph C first. So it looks like we're going down, then it looks like opposite of northwest, which is southeast, and then back up northeast. Okay, so let's go ahead, we're going to start up here, so we'll start here. Again, guys, I'm just hoping I have enough space. So what is C? So C is going to go down 1, 2, draw a vector there, turn on its side, label it C. Guys, I need you to label the vectors for me. Okay, need you to label the vectors for me. So there's C. Then we're doing opposite of A. So instead of going left 3, we're going to go right 1, 2, 3, and then down 1, 2, 3, 4, 5. Because there's a negative sign in front of it, that's what we call an opposite vector. So go ahead, draw that, label that a negative A. And then now we're just doing positive 2B. So we got to do 2 B's in a row. So right 1, up, 1, 2. Point there, label that B. And then right 1, up, 1, 2. And then label that another positive B. This is my terminal point now because that's the last point of the vector, of our last vector draw, and then my initial point is where we started C at. So we're going to go ahead now. Shading it in really heavy there, that's my resultant. And so now we're going to go over right 1, 2, 3, 4, 5, and then down 1, 2, 3. So we went right 1, 2, 3, 4, 5, down 1, 2, 3. So our component form is going to be 5, and then since you're going down, negative 3. Now guys, remember, okay, we always go from our initial to our terminal, okay? And so now we want to find the magnitude. Okay, so our magnitude again, square root 5 squared plus negative 3 squared. And so that's going to give you 25 plus 9, which is the square root of 34, which I don't know if that simplifies or not. Just have access to your calculator, so I can't think of it off the top of my head. It does not, and so there you go. I wonder if the square root of 26 simplifies. I don't think it does either. Okay, good. So there we go. So there's the magnitude of u and v. So given points 4, negative 5, and 1, negative 3, write a, b in component form. Calculate the magnitude. Okay, so for a, we're using this formula. We're going x2 minus x1, comma y2 minus y1 for the component form. Okay, so just go ahead and label it here. So you're going to go x1, y1, x2, y2. Plug that in, it's going to look like this. So x2, so that's 1 minus 4, negative 3 minus negative 5. And so then our component form for a, b is going to be this. It's going to be a negative 3, 2. The magnitude, because here we go again, how do I know magnitude? Look at the absolute value signs on both sides. Okay, so let's go up, sorry. The magnitude is just going to be the square root, okay, of negative 3 squared plus 2 squared. And so when you do that, it's going to be 9 plus 4, the square root of 13. And then C, it says sum of unit vectors. So for sum of unit vectors, I'm just taking the component form. I'm putting an I next to the horizontal component, and then a J next to the vertical component. Don't forget about your the half lines there. Okay. Give an example of two vectors that are not perpendicular. So remember, for a vector to be perpendicular, you have to do the dot product and get 0. So let's just do this. We're just going to do 1, 2, 3, 4. And now we need to show why that doesn't. So we'll call that first vector, vector A. So remember, we're doing dot product. So we're doing vector A times vector B, which looks like this. It's just A1, B1 plus A2, B2, right? And so when we do that, we're going to get this. We're going to get 1 times 3 plus 2 times 4, and that is going to give you what? 3 plus 8, or 11. And so therefore, they are not perpendicular because we did not get 0 for the dot product. Okay? All right, 6. So first things first, if this is a sum of unit vectors, let's just write it in its component form because it's a lot easier to add vectors in their component form. So it's just going to be 5, negative 2. Remember, you're just dropping the I and the J. And so it says we want a 2b minus c plus 3a. So let's go ahead and let's write that out. So 2b, so we're going to write 2 with a 5 and a negative 2 in front of it there. So that's 2b minus c, which is 2, 3. And then plus 3a, so plus 3, negative 3, 6. Okay, so let's go ahead and distribute everything on the outside first. That 2 is going to that 5 and the negative 2. And so that's going to give me now 10, negative 4. This minus sign goes through to the 2 and the 3 and is replaced with a plus because the minus sign went through. So we do negative 2, negative 3. And then this 3 goes through to the negative 3 and the 6. And so that's going to give me plus negative 9 and 18. Okay, now we're just going to add all of the same components together. So I want all the horizontal components. So it's going to be 10 minus 2 minus 9. And then the vertical components are going to be negative 4 minus 3 plus 18. And so when you add those all together, you're going to get this. You're going to get negative 1. And negative 7 plus 18 is a positive 11. And there you go. So that's vector V's component form there. Okay? Ship leaves port, sail for 40 miles in a direction of north 55 degrees east. Find the component form, ordered pair, the distance the ship sails. Again, so I would love to just go ahead and use our formula with 40 miles being our magnitude and the direction being 55 degrees, but it is not that, okay? Recall again, whenever we're dealing with a directional bearing like we are here, theta has to come from standard position, not the directional bearing. So what I'm doing is I'm going from the north here, because it says north 55 degrees east. So I'm going 55 degrees here, drawing that vector. So this is 55 degrees, okay? Now again though, to get theta in standard position, we're going to start from the positive x-axis here. And we're going to draw an angle until we get to the vector there. And so whatever that angle is, that's what theta is in standard position. And so that is going to be 35 degrees, because 35 plus 55 is 90 degrees. Okay, and so our formula is this. Okay, so I guess, I don't know, what are we calling? I guess it doesn't matter. We don't, let's say S for ship. Okay, so to find that, it's going to be this. It's going to be the magnitude, which is 40, which can be measured, cosine of 35 degrees, 40 sine of 35 degrees, okay? And so I'm just going to use my calculator, 40 cosine 35. Guys, please make sure that your calculator is in degrees. And so your component form for S is going to be 32, which is going to round to the tenth, so we're going to say 32.8. Okay, and then we're going to go 40 sine of 35. And when we do that, we get 22.9. And there you go, just wanted the component form. Which again, what quadrant are we in? We're in quadrant 1. Both answers are positive, so therefore, great shape. We know that that comes from quadrant 1. Okay? Okay, here we go. Number 8. So it says 2 hot air balloons take off at a spring festival. After about 20 minutes, the path of the first balloon can be represented by 5581. The path of the second balloon can be represented as 6277. Find the angle between. Okay, so first thing we must do is we must do the dot product between the two. And so that is going to be this. That's going to be 55 times 62 plus 81 times 77. So let's go ahead and plug those. So 55, let's do this, 55 times 62 plus 81 times 77. Hit enter, and that's going to be 9,647. Next thing we want to do is we want to find the magnitude of A. So that's going to give me the square root of 55 squared plus 81 squared, okay? I want to keep it intact. It's a lot easier that way, and it's going to not have any rounding issues. Okay, and so what I mean by that is this. I'm just going to do 55 squared plus 81 squared and see what I get, okay? And leave it under the square root. Okay, so I'm going to say square root of 9,586. Same thing, let's go ahead with B here. Square root of 62 squared plus 77 squared. Again, I don't want any rounding errors, so I'm just going to keep whatever 62 squared plus 77 squared is, and that's going to be 9,773. So now once you've done that, you can go ahead and plug it into your formula. So again, your formula is on your formula sheet. So you're going to have cosine inverse, okay, of your dot product up top there, so 9,647 all under this one square root. You're going to write 9,586 times 9,773, close parentheses, and let's see what we get there. Okay, so we're going to go double tap cosine, fraction button, we're going to go 9647 in the numerator, second square root We're going to go 9586 times 9773. Okay, and then close the parentheses on the whole thing. We do that and we find out that our angle between, we're going to round to the tenths, looks like 4.7 degrees. Okay. All right, a batter on the opposing softball team hits a ground ball that rolls out to left field. The left fielder runs towards the ball at a velocity of 3 meters per second, scoops it, proceeds to throw it to the catcher at a speed of 30 meters per second, angle of 25 degrees, with the horizontal in an effort to throw out the runner. Okay, so again, remember we talked about, this was kind of something we talked about today, all right? We've been given two vectors here, okay, both with the magnitude and direction. So we're going to use our formula here. So it looks like our first vector is just a velocity of 3 meters per second. Remember we talked about this. Whenever there's any sort of direction that we're not 100% about, we're just going to say due east, okay? So we're going to say F for fielder. We're going to set up our formula. So our magnitude, because we can measure the velocity, right? It's going to be 3 cosine 0 degrees, 3 sine 0 degrees. Again, 0 degrees is coming from due east. Okay, I'm just assuming that's what he's doing. I'm assuming he's going east as he runs towards the ball. Okay, we don't know. We're just going to assume that, all right? And so when you plug that into your calculator, you're going to end up with just 3, 0 for your component form for the fielder. Okay? The throw now, we lucked out, is a lot nicer because it gives me not only the magnitude, it also gives me the direction. So we're going 30 cosine 25 degrees, 30 sine 25 degrees. And so let's see what we get there for our component form. We're going to go 30 cosine 25. We're going to round to the tenths. I got 27.2. Okay, and then it looks like 30 sine 25 gives me 12.67, so we're going to go 12.7. Okay, so now to find our resultant, okay, to find what is the resultant speed and direction, we're going to go ahead and we're going to add those together, and that's going to give me my resultant. So my resultant is going to be 27.2 plus 3, so that's 30.2, and then 0 plus 12.7. So now it says, what is the speed and the direction, right? So, okay, I'm just going to split those into two parts. So let's do the speed for part A. So again, all we're doing is we're just finding the magnitude of our resultant because we can measure speed, right? So that's the square root of 30. I don't know why I did just a mini 2 there, sorry. 30.2 squared plus 12.7 squared. I'm going to type that into my calculator exactly as I see it. Square root 30.2 to the second power plus 12.7 to the second power. Enter. And it looks like I got 32.8. And it says meters per second, so do not forget your units, please. So it looks like the velocity of the ball is 32.8 meters per second. Now it says direction, so recall direction. We're going to go theta equals tan inverse of, it's always our vertical component over our horizontal component. So it's going to be 12.7 divided by 30.2. So again, let's plug that into our calculator here. So we're going to go tan inverse, fraction button, 12.7 over 30.2. Hit enter and it looks like we get 22.8 degrees. How do I know this is correct? Because when I look at my component form for my resultant, what do we have? Positive, positive, right? And so positive, positive means quadrant 1. And therefore tangent does work in quadrant 1. And so any answer that we get from quadrant 1 for tangent, we know we can just go ahead and square. And so the speed of the ball is at 32.8 meters per second at a 22.8 degree direction. Okay? So we just kind of did a problem like this too on number 10, okay, where we're kind of given a jet here. And this time it was really nice to us. It gave us the magnitude and the direction for both vectors. So here's the first. And then there's the wind, the second. So let's go ahead and let's set that up. So the jet is going to be this. Our magnitude is what we can measure, so 425 miles an hour. So we're going to have 425 cosine of 320, comma 425 sine of 320. All right, and so we're going to go ahead and plug that into our calculator. So I'm going to get 425 cosine 320, and that's going to give me, it looks like, around to the tenths again, 325.6. Okay, and then we're going to get 425 sine 320, and that's going to give me a negative 273.2. So there's our component for the jet. Let's look at the wind now. So the wind, it's going to be what? It looks like our magnitude is 40 miles an hour, so we're going to have 40. And then it's blowing at 290 degrees, so you're going to say 40 cosine 290. And then you're going to say 40 sine 290. So let's go ahead and plug that in. So we're going to say 40 cosine 290. And we get 13. I'm just going to call 0.7 there, round to the tenths. And then we're doing 40 sine 290. And I got a negative 37.6. So that's always our first step, is to come up with our components of each vector. We're going to go ahead now to get the resultant. We're going to add those all together. And so 325.6 plus 13.7 is going to give me 339.3. Okay, negative 273.2 minus 37.6 is going to give you a negative 310.8. So now that we have that, again, it wants to know resulting velocity and direction. So same thing we did in the problem above there. So for A, because we can measure velocity, we're going ahead and we're just trying to find the magnitude. And so it's going to be like this. So you're going to take the square root of 339.3 to the second power plus, please put a parentheses around this if you use a negative number here, because again, any negative raised to the second power will keep it negative. And so you're going to plug that in exactly as you see that there. You're going to do square root 339.3 to the second power plus a negative 310.8, not 5.8, sorry, to the second power. We're going to hit enter. And so it looks like the velocity is 460.1 and miles per hour. Don't forget about your units. All right, B, we're going to go theta tan inverse, okay, of your vertical vector over your horizontal. And so when we plug that into our calculator, tan inverse, fraction button, negative 310.8 over 339.3, close parentheses, I get a negative 42.5. Okay, now again, what quadrant are we trying to go to though? Okay, obviously a negative angle does not work for us. And so what quadrant are we trying to go to? Well, we look at our component form for our resultant, and we have positive x, negative y. So that's quadrant 4. And so that means that I'm going to add 360. And so when I do negative 42.5 plus 360, I get 317.5 degrees, and there you go. That's your answer. That's your direction. Again, why did I add 360? Because I'm trying to go to quadrant 4, okay? If you're going to quadrants 2 and 3, you would add 180 to your answer, all right? Okay, here we go, last one. The lighting system for Milton is supposedly equal by 2 cables suspended from the ceiling of the auditorium. The cable forms a 140-degree angle with each other. The lighting system weighs 950 pounds. What is the force exerted? Okay, so it's going to look something like this, kind of with what we worked on the notes. Well, it was on the notes today. Okay, so, you know, just a light there. So it says between the two, it is 140 degrees, okay? Now, because of equilibrium, guys, we know then that the weight being forced on both sides here is going to be half of what the total weighting of the system is. So you do 950 divided by 2, and you get 475. Again, guys, you're always forming right angles with these, okay? Now, what we need to understand is that from here to all three of these angles, they form a linear pair, right? And so a linear pair forms up to be 180 degrees. So that means then that this angle right here has to be 20 and this has to be 20. Because 20 plus 140 is 160 plus another 20 is 180. And so that's where I got this from, because linear pairs. Okay? And so recall, what are we trying to find here? We're trying to find a magnitude of the hypotenuse. And so this is how it's always going to be, guys. Set it up like this. You're going to get sine of 20 degrees equals 475 opposite. Why am I using sine? Because opposite over hypotenuse, the magnitude of t. So now to solve, we're going to go ahead and multiply both sides by the magnitude of t. So you're going to have the magnitude of t times sine of 20 degrees equals 475. And then you're going to go ahead and divide by sine of 20. And so then the magnitude of t is equal to fraction button 475 over sine of 20 degrees. I hit enter and I get 0.8, and then let's go pounds, yep. Again, guys, you're going to be having two right triangles because of equilibrium pulling it down here the same weight, right? And so why did I get 475 on both sides? Because it has to be equal because of equilibrium. They both have to be having the same exertion of weight on both sides, okay? How did I get that 20? Well, I was told that the two cables form 140 degrees. You need to understand that these two angles right here with this angle formed by the cables is a linear pair. A linear pair is multiple angles that add up to 180 degrees. Okay? And so, again, that's how we find out to be 20 and 20 there. Once I have that, I just do sine of 20 degrees equals opposite 475 over hypotenuse. Guys, if you practice this enough, you will see that this method does not change from question to question. Okay? And so make sure you have that understanding of that. Okay? All right, so pretty lengthy, but not as bad as I think the last quiz review, which I think was somewhere near 40 minutes. All right, so that is it. Okay, and we will go over any questions you have tomorrow in class. All right, thanks, guys.